Hello. What if you could go to the deepest of the internet? What if you could be at two places at the same time? Well, that's what I'm going to show you today. Behind me, I have myself on both sides. This is an effect in the quantum world known as superposition. Superpositions can be really fragile. So as soon as I run it through a filter, or I turn around in my case, it turns to either 1 or 0. In my case, right or left. To better understand this whole thing, we have to go to the days of the classical computer. To examine how quantum computers work, we have to start by taking a look at classical computers. Classical computers, like you're watching on right now, make up still images of me to display the video. Those still images have thousands of pixels in them. And those pixels have colors, and those colors are made up of ones and zeros, which in other words are known as a bit. A bit is a small transistor that is the smallest component in a PC. Imagine it like this. A classical computer solves problems just like if an ant were to cross an ant farm or a maze. It evaluates and examines problem one by one and finally coming up with the right one. Although it takes time, it does work. Although these types of computers are capable of computing our daily tasks, they're not capable of handling uncertain things. A great example of this could be things that happen in nature and the whole universe. So in order for scientists to factor in uncertainty, they created what's known as the quantum computer. Unlike classical computers, they have what's known as qubits. Just like a bit, qubit, when it's turned off, it has ones and zeros. But as soon as it turns on, qubits go into a state, what I referred to earlier, named superposition, where they're both 1 and 0 at the same time. This is just like when you flip a coin. You have no clue whether it's heads or tails until you take a look at it. This is another example of the bicycle effect I showed you earlier. Solving a problem with a quantum computer is just like if you put millions of ants in a maze trying to find their way around. All the ants will try at the same time to find the best path from one end to the other. This will be much faster and more efficient. This is able to be achieved by qubits because they're able to hold uncertainty in their head. The next thing which is special about the quantum computer is the fact that entanglement happens. This happens when two qubits correlate with each other, and the final state of the outcome of either qubit could be determined by the other, no matter how many light years away these are. Experiments conducted by John Bells found the fact that these qubits can communicate with each other in a speed faster than light. Although they won't be replacing our current computers, quantum computers have the power to do incredible things, from the rapid growth of artificial intelligence to the finding of different kind of medicine. You could go to IBM's quantum experience and start today. Yes, you.